Calculus AB, section 3.9, page 5. And we are going to take a look at an example of the last reason that we might want to do logarithmic differentiation, and that is to avoid a nasty product rule, quotient rule combination. Look at this mess. Oh, there's a quotient rule and a product rule in the numerator and a chain rule with that square root. This just becomes a nightmare in trying to do the derivative with all the product and quotient and chain rule going on. So if we try and crank through this with logarithmic differentiation, the calculus part is easy. So let's start. The first thing that we're going to do is to take the natural log of both sides. So the natural log of y is the natural log of x times, well, I know I'm going to have to get rid of that square root, so I might as well do it right now. X squared plus 1 to the half over x plus 1 to the 2/3. Alright, now rewrite that using our log rules. And there's a whole lot more log rules in here than just that leaping exponent out here. We have a product here, we're going to break that apart as the sum of the logs. We have a quotient here, we're going to break that apart as the difference of logs. So here's rewriting it in using those log rules. ln y equals, alright, we have the natural log of x. And it's multiplying by this mess, so that's going to be plus. And at the same time, I'm going to pull that half leaping exponent down in front. 1/2 ln x squared plus 1. And then, because we're dividing that by this piece, we'll subtract natural log of x plus 1 to the 2/3. But let's go ahead right away and pull that 2/3 leaping exponent down in front. So we've rewritten this using our log rules. Now let's go through and let's do a derivative of both sides. So the derivative of ln y, that's 1 over y times dy dx. The derivative of an ln x, that's 1 over x. Plus this derivative, the half comes down. The derivative of the natural log x squared plus 1, that's 1 over x squared plus 1 times the derivative of the inside, which is 2x, and then minus this one, 2/3 natural log of x, 1 over x plus 1 times the derivative of the inside times 1. Alright, now let's clean this up. 1 over y dy dx equals, we have a 1 over x plus, oh how nice is this? The 2's are going to divide out. We'll be left with x over x squared plus 1 minus 2 over 3 times an x plus 1. Alright, now let's go through and let's solve for this dy dx, which means we're going to pull that y over. So y times this big mess, 1 over x plus x over x squared plus 1 minus 2 over 3 times an x plus 1. Replace out that y. And, ooh, what a mess. X times an x squared plus 1 to the half over an x plus 1 to the 2/3 times this big old mess. Alright, now, yes, we are going to go through and simplify all of this. We are going to add these three fractions together and see what happens. maybe we'll get something to cancel out and it'll actually end up looking out very nicely. All right, common denominator between these three fractions. Common denominator is going to be, a 3 and x. We'll need an x squared plus 1 and an x plus 1. All right, to get from this first fraction 1 over x to this denominator, we are going to need a 3, an x squared plus 1, and an x plus 1 to be multiplied by that 1 up there. Now, for this middle fraction, we already have the x squared plus 1, so we're just going to need that 3x and x plus 1 times that x. Minus this last fraction, we already have the 3, we already have the x plus 1, we're going to need to multiply that 2 by an x and an x squared plus 1. All right, let's keep going. All right, we're going to need to multiply all this stuff out and combine some like terms in here. I'm going to go ahead and square or multiply out this x squared plus 1 times that x plus 1. And then when I get each term, I'm just going to go ahead and multiply by 3 all at the same time. So x squared times x is x cubed times 3, 3x cubed. X squared times 1 is x squared times 3 is 3x squared. 1 times x is x times a 3. And 1 times 1 times 3 plus a 3. This middle set, I'm going to think about this as 3x squared times x plus 1. So 3x squared times an x is 3x cubed. 3x squared times a 1 is a 3x squared. And then the last one's easy. Minus 2x cubed minus a 2x all over 3x times x squared plus 1 times x plus 1. Oh boy. All right, let's go through and combine some like terms. X squared plus 1, x plus 1. All right, let's see. My x cubed, I have a 3x cubed and another 3x cubed. That's 6x cubed minus 2x cubed. There's 4x cubed. The x squared, so we have a 3x squared and another 3x squared. That's plus a 6x squared. A 3x minus a 2x plus an x. Oh, and then the last one plus a 3. Whew. All right, everything's multiplied out. Now let's see if we can simplify this more still. All right, we're multiplying the numerators and the denominators. But look at this. How about this x right there with this x down here? Won't those divide out? Sure, those will go away. All right. How about this x squared plus 1 to the half and this x squared plus 1 down here that's to the first? Yeah, those will divide out. Not completely out, it'll leave you with an x squared plus 1 to the half down here. And then nothing else cancels, but we do have this x plus 1 to the 2/3 times that x plus 1 to the first. And that will give us an x plus 1 to the 5/3. So here's our final answer. Then all that's left on the numerator is 4x cubed plus 6x squared plus x plus 3 all over, and we have a 3, an x squared plus 1 to the half, and an x plus 1 to the 5/3. That's it. If this factors, you should try to factor that. It doesn't. It was 4 terms. We'd have to go by grouping. Out of here, you'd have to have an x plus 3. And you're not going to get, if you pull a 2x squared out of here, you will not get an x plus 3. So nothing's going to factor. All right. Let's go back and let's just identify what's everything that happened here. From beginning to here to this step, that's all your pre-calculus. Going from here, this step, to that one right there, that's calculus. And the rest of this, solving an equation, multiplying both sides by something, getting common denominator with rational functions, this is all algebra. All algebra. All right, just a note here. Doing the logarithmic differentiation this way, so that doing the derivative on this one using logarithmic differentiation, the calculus is easy, the algebra is messy. If we were to do this as a product rule quotient rule combination, the calculus would be hard. Cranking out the derivative with product rule and quotient rule is hard. The algebra is a little bit easier to handle, but the calculus is a lot harder. So we tend to go this route, keep the calculus easy, and then go with our old algebra skills to get an answer. Thanks for tuning in.